Hello geometry students, this is Mr. Fugay, and our video today is going to talk about trig functions on the coordinate plane. So this is going to be the Avengers Assemble in terms of taking the right triangle trigonometry we learned back in Unit 5 and merging it together with all the work we've done with radians and circles in Unit 6. So let's start with this, and I have up on the screen our trig functions. So we probably remember them from a couple units ago. SOHCAHTOA is how I best remember them. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. Then over on the left here, I have on the coordinate plane 4 triangles drawn. They are drawn, as we will talk about in coming lessons, in a standard position. And the standard position meaning that the theta is always going to be the angle that is closest to the origin. So these are angles that we will eventually realize are created from drawing angles in standard position. So you will notice something here. When we look at all 4 of these triangles and where the angles are located, we will see that all of the opposite sides are going to be these vertical lengths that you see here on screen. And all of those vertical lengths can be represented on the coordinate plane by y. So all of these values are going to be y. So when we define the sine function or the tangent function on the coordinate plane, we're really going to view opposite as the y value of the triangle. So let's go ahead and fill that in, okay? The next one is our adjacent side. So if we were, for example, defining cosine, we would look at the adjacent side. And I want you to notice that both adjacent sides of all 4 of these triangles, actually, not both, is going to be the x-axis, or the x value of the triangle. So anywhere where I see adjacent written, we're going to write an x. And then our final side, the hypotenuse, this is going to be the one that's a little bit strange, at least initially, until we define some more items. But all of these hypotenuses that I'm tracing out for you are all going kind of in a diagonal direction out from the origin. Now we are going to give this a name, and I forgot to put the x here and here. We are going to give that a name, and we're going to actually call it r. Now you can take some hints if you want why it's called r. It will make more sense in our next lesson. But we're going to define the hypotenuse now as r. And so what you're going to see here on the right-hand side is I have redefined the 3 original trig functions. Rather than using SOHCAHTOA, we're using coordinate values instead. Now, you can always remember SOHCAHTOA because that's going to help us in any context using sine, cosine, and tangent. But when the trig functions are plotted on the coordinate plane, when triangles are plotted on the coordinate plane, sine is always going to be y over r. Cosine is always going to be x over r. And tangent is always going to be y over x. And just as a reminder, I haven't forgotten about the other 3, cosecant would then just be the reciprocal r over y. Secant would be the reciprocal r over x. And finally, cotangent is going to be x over y. Now, what we're going to do with this is we're actually going to try to create a couple problems together. So let's take a look right now at one of those. So we're going to skip over the bottom part of the notes. We're going to come back to that at the end. Let's look at example 1a. It says, if theta is an angle in standard position and the terminal side passes through -512, find the value of all 6 trigonometric ratios. So this is always going to lead off with using the coordinate plane. And I want to also note that this point right here is going to be located in quadrant number 2 because it has a negative x value and a positive y value. Because one of the things that we'll talk about at the end here is that these values of x and y in particular may be negative. In fact, we'll add it in right now while I'm back here, is that this x value right here is going to be negative. These y values here and here are going to be negative based on the definition of how points are created on the coordinate plane. You'll also note that I did not make r negative ever because it is always going to be a positive value. So let's go ahead and let's draw a picture here. So -512, we're just going to draw a sketch. I'm literally going to write -5 there. I'm going to write 12 up here. We're going to plot a point, draw in that terminal side, and how we're going to create our triangle in quadrant 2 is we are going to drop a vertical line from that point all the way down to the x-axis, and then of course our x-axis is going to be one of the sides as well. The reason why this is important is that we can actually say that the length of this side of the triangle would be -5. And yes, I'm putting the negative there to help us denote direction. And then this is going to end up being 12. So what we can do right now is we have our right angle formed here, just like we did with right triangle trig. We have our angle theta here, and what we need to do is we need to find our trig function. So sine, cosine, and tangent. And then we're going to find cosecant, secant, and cotangent. Now, to figure that out, for example, tangent can actually be found right now in this moment because tangent is the opposite over the adjacent, or in our new definition, it's y over x. So we would say that the tangent ratio is 12 over -5. And yes, tangent will be a negative value when the triangle is in quadrant 2. Cotangent's the reciprocal, so we would say that this is -5 over 12. Now the issue is for sine, cosine, cosecant, and secant, we do not know the hypotenuse, or what we are now calling the r value. And so the way that we're going to do that right now is just do a quick Pythagorean theorem. So we're going to do 12 squared plus, yes, we have to say -5, but know that that's going to become positive when we solve this. So we get 12 squared, which is 144. -5 squared is positive 25. And when I add those together, that's going to give me 169 equals r squared. Take that square root, and now we know that the r value is 13. It will always be positive. R is always positive. We'll talk more about why that is in coming lessons. But now that we know what the r value is, we can now figure out what sine, cosine, cosecant, and secant is. Sine is opposite over hypotenuse, or now we can call it y over r, 12 over 13. Notice that's positive, by the way. Cosine is adjacent over hypotenuse, or x over r, so -5 over 13. And of course, cosecant and secant are just reciprocals, so we're just going to go ahead and flip our two answers. 13 over -5. And what you will see here, one thing to note, is that the sine value ended up being positive as well as cosecant, and then our cosine and our tangent, as well as their reciprocals, were negative. So we're now going to have to compete with this idea that sine, cosine, and tangent may be positive, and sometimes they might be negative. We're going to talk about that at the very end of the video. So what I want you to do now is I want you to try 1B, and then what I'm going to do is I'm going to walk through that problem. So go ahead and pause this video first, and then we'll walk through the problem next. Okay, hopefully you've paused. I'm going to take note that this is going to be in quadrant number 3. So when I draw -8, -15, that's going to be my x value. That's going to be my y value. Notice I don't have to, these are just sketches of triangles. So where you put it is kind of not that important. We have our terminal side drawn, and we're now going to draw a vertical line to create our right triangle. Noting that the x value of this triangle is -8, and the y value is -15. So just like we did in the last problem, we need to find sine, cosine, and tangent. And then we also need to find their reciprocals, cosecant, secant, and cotangent. Once again, just like the last problem, our theta is always going to be closest to the origin. And we technically already have the numbers we need for tangent. So let's talk about that one first. That's going to be -15 y over x. Now, because both values are negative, that's actually going to make the tangent ratio be a positive answer, 15 over 8. So let's keep in mind that we have to simplify when we are able to. This will make cotangent then positive 8 over 15 for the same reason. Now, the next thing we need to do is our Pythagorean theorem to figure out our r value. So in this case, that is going to be -15 squared plus -8 squared equals r squared. That's going to give me, 225 plus 64 equals r squared. And a lot of these first problems, I'm having them come out as perfect squares. I've actually got ahead of myself there. That's 289, which then when you take the square root, gives me an r value of 17. So now we can find our sine and cosine ratios, which would be -15 over 17 and then -8 over 17. And to find the reciprocals, well, it's going to be 17 over -15. And lastly, 17 over -8. Let's take note that the sine and cosine ratios are going to be negative as well as their reciprocals. And in this situation, the tangent ratio is the one that actually ends up being positive. So when a triangle is in quadrant number 2, sine was positive, cosine and tangent were negative. In this problem, in quadrant 3, tangent was positive, sine and cosine were both negative. So the last problem I want you to try for this one is 1C. So once again, pause this video, try this out, and then we will talk about it in just a second. All right, so for this one, I have the full solution written out. You'll notice that this was in quadrant 4 this time, so I plotted my point here, drew my terminal side, and then created my vertical line to make my right triangle. Theta, again, is close to the origin. I have my y value and my x value graphed, which, by the way, allows me to find tangent, which notice this one, it simplifies to -2 in this situation. Cotangent's the reciprocal. I go ahead and do the Pythagorean theorem, which all the work over here is shown. Notice this time it is not a perfect square, so I wrote the answer in simple radical form. This is actually interesting because now when I find my sine ratio, we'll see that it actually is going to simplify to -2 over root 5. And for cosine, the 2's cancel out, become 1 over root 5. Yes, these two could be rationalized, but at this moment of time, we're not going to worry about that. We're just going to focus on creating the ratios. I want you to take note before we wrap up that the cosine ratio and its reciprocal were positive in this situation. Sine and tangent were negative in this problem. So notice as we went through these three problems, in quadrant 2, sine was positive. In quadrant 3, tangent was positive. And in quadrant 4, cosine was positive. So this is what we're going to wrap up. We're going to head back to page 1 and wrap up and talk about why this is happening. Okay, so we're back on page 1 here at the bottom, and you'll notice that I never gave us an example where a triangle was in quadrant 1, and that's because in quadrant 1, everything's positive. Since the x and y coordinates are positive, and I want you to take note here that the hypotenuse or the r value will always be positive, we had no issues with negative signs in quadrant 1. The reason that cosine and tangent were negative in our quadrant 2 is because the x value or the adjacent side is negative, and that's what forces cosine and tangent to be negative. Since sine does not have an x value or adjacent side in, that's why it was positive. Moving down into quadrant 3, sine and cosine were negative because both x and y in this situation were negative values, and that is the reason why they came out negative. And tangent, oddly enough, since it has two negative values to create it, is the reason why it is positive. And finally, you'll see over here in quadrant 4 that because the y value is negative, or the opposite side, this is why sine and tangent are both going to be negative. So when we zoom out and we take a look at this as a whole, we can actually use a shortcut to help us remember where certain trig values are positive versus negative. So in quadrant 1, all of the trig functions are going to be positive. I'll box that in. In quadrant 2, sine is the only one that is positive. In quadrant 3, tangent is the only one that is positive. And finally, in quadrant 4, cosine is the only one that's positive. Now, I'm highlighting the letters and wrote them really big to help us quickly remember what quadrants has what positive values. Now, you'll notice I'm not mentioning the cofunctions or the reciprocal functions because they always will have the same values as their counterparts. So if you just focus on sine, cosine, and tangent, that's ultimately all we need to know. So I like to remember this. ASTC for the quadrants, all, sine, tangent, and cosine. Now, there is a silly, what I call mnemonic device, which helps us remember ASTC as we're looking through the quadrants. And that is, I like to use the term, all students take calculus. And just take it as your geometry teacher loves calculus, he teaches calculus, and that's why I believe all students should indeed take calculus. And because of that statement, it will hopefully help you remember where trig functions are positive and where trig functions are negative. And we're going to work in the coming lessons on developing that skill and becoming more proficient in that. But that's it for this video, and that is part 1 of this lesson. So now it's time for you to practice and put it in your own hands and see how things go. On that note, have a great day and happy trig.